All righty, let me go ahead and share my screen. This. All right. All right, let me go ahead. All right, so this is gonna be about diffraction grating. Now, hopefully, you already learned about this point, about the double slit experiment. And from the double slit experiment, it shows we conclude that it showed that light can have wave like interference pattern. Basically, and actually, let me get a green on this one. If you shine a green laser through a double slit, you will see a bright spots. And dark spots. Next to dark spot, and it goes there. It goes dimmer. So basically, let's say this is our detector wall over here. So we have a little double slit right now, right out over here, where this is going to be our distance D. And let's say if you shine a green laser, so what we're going to do, you're going to see a bright spot. So this is your bright spot over here, which constitutes, let's say this is your big wave. Then it goes in a little dimmer, then a dimmer spot, and as much as it goes. Now the distance from this bright spot, the detector, to the next bright spot, let me actually try to draw a full line on that one. Let's say this is your next bright spot. This is going to equal to your angle theta. And where your delta x is going to equal to this one over here. There's going to be your distance delta x. So basically, at these points, And let me get it. At these points over here, they go dimmer and dimmer and dimmer. You barely can see them. So basically, the images or the spots gets really dark. The further you go. So you can barely see them, even the fifth and the sixth one. So they die off quickly. And the question is there a better way? So is there a better way to make these spots more brighter? So you got a double slit over here coming in. This is going to create your angle theta, where this is your x, where your delta x is going to equal to 1 lambda, 2 lambda, 3 lambda, etc. And it's going to go dimmer and dimmer the further you go. And the spots going to go, they die off quickly. So this is going to be your first one, first spot, second spot, third spot. By the fourth or the fifth spot, you barely can see it. So the question is there a better way to make these spots more brighter? And let me put my little question mark. And the answer is absolutely yes. But how? So how? By making more holes. So you get your little detector screen, and this time instead of having 2 holes, you're gonna make more holes. So let me actually go, and what I'm gonna do, I'm gonna just throw it down. Let me get a bigger detector right now over here. Let's say you got multiple lines of band. One more time. Let's try this one more time. All right, let's say these are my holes right now over here. Now, by making more holes, all of them have the same distance. D, 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 and this one will be distance D. And what we end up having is multiple bright spots. So you're going to get a bright spot over here. Let me get red. You're going to get a bright spot over here. You're going to get a bright spot over here. You're going to get a bright spot over here. You're going to get a bright spot over here. So instead of getting a single pattern, you will get a bright dot next to darkness. So you got a big bright spot, darkness, big bright spot, darkness, big bright spot, darkness. Now, looking at the distances. So here's your distance for, let's say, your first one, for your first spot, going in to the grating. You're going to drop down a perpendicular line. So this one right now over here, that's going to be your delta X. So basically, this delta X will be the distance the light traveled. And over here, your delta X is going to equal to 1 lambda. All right. Looking, let me go to a different color. Let me go again and get a green. All right. So you got from over here to the third line, the third hole. What you going to have? This is going to be the distance that it traveled. Let me go ahead and color it in green so you can distinguish between it. What you notice is going to be twice as delta X. So this is going to be 2 delta X's. So basically, this light travels twice as much as the first one. So let's say this is our wave over here. So here's your delta X at 1 lambda. And this one, 2 lambdas, you'll be right now over here, 2 lambda. All right, what about the third hole? Well, let's do the third hole. So if you actually look at the third hole, let me get purple. So this to this slide, this is bright spot, going down the third hole, dropping this down. You're gonna notice that this line over here that I'm gonna color, that's gonna be 3 times as much times the, let's try this better. Basically, the light travel 3 times as much. So here's, it will travel to right now over here. Let's say this is going to be a 3 lambda. Let's say the light shifted. If you shift it, let me get a yellow. So let's say you go over here on the next bright spot where your delta X 1.1. So this one would go ahead to this next bright spot. Let's say this is your bright spot over here. I'm trying to get a straight line. And let's say this is your next bright spot. So your line will be right, a little shifted right down over here with delta X. So your 1.1 shift will be right over here. This is going to be 1.1 lambda. And if you actually move in, let's say to the next point, so this will be your 1.2 lambda, and so forth. You get to the darkness, then it goes brighter, 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 the second lambdas, and so forth. So let me go ahead, get this one in. Instead of getting the single pattern, you will get bright spots next to dark spots. And again, the bright spots and dark spots are the bright spots are going to be well defined. And again, the two waves coming into the first hole meet at the bright spot delta equals 1 wavelengths, 1 lambda. And you'll end up creating, let me go ahead and do a little thing of this. So let's say this is your bright spot. The distance D, delta X. And we go ahead and actually, let me go ahead and flip the triangle. So basically you would get a triangle that looks like this, where this is going to be your distance D, this is going to be your delta X, and flipping this triangle, going in. Let me draw this triangle right now over here. This is D, delta X. You're going to get your sine theta. You're going to get angle theta, and your sine of the angle theta is going to equal to your delta X over your D. That means your D sine theta is going to equal to your delta X. And so basically, this is what we call your diffraction grating. And this, your D sine theta, holds true for all holes. And we're talking about thousands of lines per centimeter. And when you hear the word lines, this is your holes. So basically, when you talk about your lines, per centimeter, you talk about how many holes per centimeters. And again, you're going to have thousands of lines per centimeter. And that's about diffraction grating. If you have any questions, just go ahead and get in touch with me at abunaem at uah at gmail, abunaemeh at gmail.com. Thank you so much.